Hello, today we are going to start with 11th class contains two chapters of organic chemistry. 12th chapter some basic principles and techniques and 13th chapter hydrocarbons. Starting with first part of organic chemistry, some basic principles and techniques. So, what is organic chemistry? Compounds like urea, sugar, oil, fats, dyes, proteins, vitamins, which were isolated directly or indirectly from living organisms such as animals and plants, were called organic compounds. The branch of chemistry which deals with the study of these compounds were called organic chemistry. Compounds like common salt, marble, alums, vitriols, which were isolated from non-living sources such as rocks and minerals, were called inorganic compounds. The branch of chemistry which deal with the study of these compounds was called inorganic chemistry. Organic chemistry is also defined as the chemistry of carbon compounds containing usually hydrogen and one or more additional elements like oxygen, nitrogen, sulfur, halogens, phosphorus. Inorganic chemistry is defined as the chemistry of all elements other than carbon and their compounds. Tetravalency of carbon. Electronic configuration of carbon is 2 and 4 because atomic number of carbon is 6. Carbon has 4 electrons in the valence shell and thus needs 4 more electrons to complete its octet. Therefore, carbon is tetravalent. It is energetically very difficult for carbon to either gain or lose 4 electrons to achieve the nearest inert gas configuration. Carbon always combined with other atoms by mutual sharing of electrons and thus forms covalent bonds. Since all the organic compounds contain carbon as the essential elements, therefore the nature of chemical bonding in organic compound is always covalent. Carbon is always tetracovalent, that is, it forms 4 covalent bonds with other atoms. The 4 bonds of carbon atom are directed towards the 4 corners of a regular tetrahedron. That is, the angle between any two adjacent bond is 109 degree 28 minute. Study with orbital picture of methane. It's shown orbital picture of methane. CH4 is a tetrahedron. It's quite visible on the screen that carbon is sp3 hybridized and bond length is 108.9.5 degree. And what about ethene molecule? The carbon-carbon double bond of ethene consists of strong carbon-carbon sigma bond and a weak carbon-carbon pi bond. It's shown that carbon-carbon double bond. One is sigma and other is pi and hybridization is sp2. Ethyne molecule. The carbon-carbon triple bond of ethine consists of a strong carbon-carbon sigma bond and two weak carbon-carbon pi bond and hybridization is sp high. Structural representation of organic compounds. First of all, start with complete and condensed formula. It's shown on the screen CH3 single bond CH3 means it is C2H6. It means it is ethane. It contains 2 carbons which are single covalently bonded. Each pair of electron making a covalent bond is represented by a dash. Dash means covalent bond. 2 dashes represented a double bond and the 3 dash represent a triple bond. Similarly, in case of C2H4 means carbon and carbon are doubly bonded, C double bond C. It is case of ethene. Now what is in case of ethine? C2H2. It It means C triple bond C. And what about case of CH3OH, methyl alcohol or methanol? Such structural representation is displayed formula. These structural formula can be further condensed by enclosing the repetitive structural unit with a bracket and placing an integer as a subscript, indicating the number times its structural unit gets repeated. For example, if you have an expanded formula CH3, CH2, 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 CH3. It means how many times CH2? There was total 5 times CH2. Term which is repeated, same, it can be put by repeating its subscript. It means it can be written as CH3, CH2 5 times CH3. If you are with example CH3, CH2, 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 COOH, it can be written as, means it can be condensed into CH3, CH2 6 times COOH. Okay, let us start with bond line structural formula. It is a simple, short and convenient method of representing organic molecule. Carbon-carbon bonds are shown by lines drawn on a zigzag fashion and carbon atoms by lines, ends and intersection. A single bond is represented by a single line, a double bond by two parallel lines, and a triple bond by three parallel lines. Carbon atoms are not shown, but all atoms other than carbon and hydrogen atoms such as oxygen, nitrogen, halogens, they are shown. Each carbon on the line or intersection is attached to required number of hydrogen atoms, that is terminal denotes CH3 group and substituent intersection denotes CH2 group. For example, butyl chloride, it is shown on the screen. It contains 4 carbon atoms. It means it has 4 tips, means 4 intersection. Okay. Now polygon formula. Poly means many. If there are many carbon atoms, these are many organic compounds. There are many organic compounds in which carbon atoms are not joined in a chain but are joined in a ring. These are called cyclic compounds and are usually represented by polygon without showing carbon and hydrogen atom. The corners of polygon represent a carbon atom and the sides of polygon denote a carbon-carbon bond. If an atom or group of atoms other than hydrogen is attached to carbon, then that atom or group of atom is shown in this structure. For example, you are dealing with cyclopropane. Once you are clear about cyclopropane, it contains how many carbon atom? It contains 3 carbon atom, but in case of cyclo word, cyclo indicates it's a polygon formula. It means there must be less number of hydrogens so that it cannot be written in term of chain. That's why it is written as a closed structure. So 3 dots, always there is formation of a triangle. Similarly students, you try to write down cyclobutane. It means but means 4 carbon atoms. And whenever 4 dots are there, the easiest available polygon is a square or a rectangle. Okay. 3-dimensional representation of organic compounds. On the screen there is 3-dimensional representation of methane, CH4. The 3-dimensional structure of organic compounds can be represented on paper by using certain conventions. By using solid dashed wedged formula. The thick solid line or solid wedge indicates a bond laying above the plane of paper and projecting towards the observer. A dashed wedge is also used to represent a bond laying below the plane of paper. Wedges are used in such a way that they are pointed towards the observer. And a representation which completely describes the actual position of a various atoms of molecule in space is called special formula of three-dimensional, that is 3D structure. Okay, thank you so much.